Hello and welcome to the Inelastic Collisions video tutorial. Here we have two cars in a head-on collision. They will collide, and then the combined cars together will continue to move to the right until they collide with the green car. We're solving for the final velocity of the three cars when they're all coupled together. Well, we're going to do this in two steps, starting with the blue and red car. Well, we know that the momentum before the collision is equal to the momentum after the collision. So we can do this by saying the mass of the first car times the velocity of the first car plus the mass of the second car times the velocity of the second car is going to be equal to the mass times velocity of the first car and mass times velocity of the second car after the collision. So we'll just copy and paste this. So these here represent the total momentum of the system before the collision occurs, and this represents the momentum of the system after the collision occurs. So these velocities are not necessarily the same velocities. It's like this v1 is not necessarily this v1. Alright, so let's start plugging in values. 20 times 4 plus 8 times negative 2. That's a negative 2 because the car is moving in the negative direction, is going to be equal to the mass of car 1, which is 20, times v1 plus 8 times v2. Now something to keep in mind is that after the cars collide, because they're connected, they have the same velocity. So after the collision, the velocity of car 1 and the velocity of car 2 are the same, so there really is no v1 and v2, it's just velocity. So 20 times 4 is 80, plus negative 16, so let's make that a minus 16, equals 28 times the velocity of the system after the collision. So 80 minus 16 is 64, and that's going to equal to 28v. So the velocity is 64 divided by 28. The velocity of two cars combined is 2.286 meters per second. So that's the velocity of these two cars after they've connected. And because the velocity is positive, that means that the cars are moving to the right, which is what you would expect anyway, because you have more mass and velocity out of this car than you have out of this car. So this car is clearly going to overpower this car, and they're going to move to the right. All right. To do this again, for the green car, we're basically just going to do this whole process again. So this really is the same. Let's break that up. So you can see this is a new problem at this point here. So the momentum of the combined blue and red car together, moving to the right, interacting with the green car, is going to equal the mass of the blue and red car together times the velocity of that car after the collision and the green car and its velocity. So the mass of this M1 now stands for the blue and red car put together, so that's 28, moving with a velocity of 2.286 meters per second. Well, 15 is the green car, and it has no velocity because it's not moving. This is going to equal the mass of the combo, which is 28, times an unknown velocity, plus the mass of the green car at its unknown velocity. Now, just like last time, when the blue and red car, which are now combined, run into the green car, which combine again because that's what inelastic is, the three cars will all be moving at one velocity, so there really is no v1 and v2, there's just velocity. So 2.286 times 28 is equal to 64 plus 0 because 15 times 0 is 0, is going to be equal to 28 plus 15v, which is 43v. So 64 divided by 43 is going to give a final velocity of 1.488 meters per second. Okay, we're going to do this problem again, but this time we're not going to do it in 2 steps. We're just going to take the velocity of everything, the momentum of everything, and set it to the momentum of everything to show that you really don't have to do it this way. So the momentum of the system before the collision should equal the momentum of the system after the collision. So it's basically this again. But the difference this time is that because there are 3 objects, M1, M2, and M3, because we're not doing this in 2 steps, we're just going to add the M3 V3 term. And this is going to be for after the collision. All right. Now something to notice, when the 3 cars collide and all stick together, they'll all be moving with the same velocity because they're all connected, so there really is no V1, V2, and V3 after the collision. There's just V. So we can rewrite this. We can take the first half of the equation. That's the same. This is before the collision occurs. And we can just say this is equal to M1 plus M2 plus M3 quantity times the final velocity of everything. So now we can plug all this stuff in. So we have 20 times 4 plus 8 times negative 2 plus 15 times 0. And that's going to give us 20 plus 8 plus 15 times v. So 20 times 4 is 80 minus 16 plus 0, space, equals 28 plus 15 is 43 v. And you can already see this is turning out just like last time. 64 equals 43v. Well, 80 minus 16 is 64, and that equals 43v. So sure enough, you do not have to do this in 2 steps. You can do it all in one big step and get a final answer of 1.488 meters per second. And it asks for direction because the answer is positive, and we've established positive to be right. Final answer is to the right. Thank you for watching the Inelastic Collisions video tutorial.